Hi all, welcome back. Today we're going to be doing 5.8 notes on exponential growth and decay. Up here is just the formulas that we're going to be using down below, and I'll explain which problems we're going to use for each formula. So let's go ahead and do this first one, and it says, a colony of bacteria increases according to the law of uninhibited growth. So we are talking about growth, so we're going to be using that general formula for growth and decay. Part A, if n is the number of cells at time t, write n as a function of t. So basically, instead of using a sub 0, which is like our initial amount, we're just going to be using n instead of a. So we're going to rewrite that same formula just with using n. So n t equals n sub 0 e to the kt, and this is growth, so k is greater than 0. Alright, so if the number doubles in 3 hours, we want to find k. What is k if our number is doubling in 3 hours? So our initial value doubled, so 2 times the initial value equals n sub 0 e, and then we don't know k, but we know t is 3. So those n sub zeros cancel on both sides. So we're left with t equals e to the k 3k. And then I'm going to take the natural log of both sides. And instead of log, because if I do natural log times e, I just left with that exponent. So that's why I'm choosing natural log here. So natural log 2 equals 3k, and I want to solve for k. So I'm going to divide by 3. So natural log 2 divided by 3 equals k. And then I can just leave this as natural log 2 divided by 3. So now I want to know how long will it take the colony to triple. So now 3 times the initial amount. So 3 n sub 0 equals n sub 0 e. I do know k. We just found k in the last example. So natural log 2 divided by 3, but I don't know t. That's what I don't know, and that's what I'm trying to find. So again, my n sub 0's cancel. So I'm left with 3 equals e to the natural log 2 over 3 times t. I'm going to take the natural log of both sides times t. Then I'm left with natural log 3 equals natural log 2 divided by 3 times t. I'm solving for t, so I'm going to divide both sides by natural log 2. So natural log 3 divided by natural log 2 divided by 3 equals t. If you plug this in your calculator, you get this equals about 4.76, and then the time is hours. Okay, so this next example, it says traces of burned wood contain about 1.67% of the original amount of carbon-14. If the half-life of carbon-14 is 5,700 years, about when was the tree cut and burned? So here again, we're looking at like the half-life. So, but we're not exactly given everything we would need to use that specific half-life formula, because we're trying to find about when was the tree cut and burned. So like time, that's what we're trying to figure out. So we need to use the growth and decay formula. So the first thing that I know we have is we're trying to find the half-life. So half the initial amount. So we're trying to find half a sub 0. And so we're going to use our formula, a sub 0, e, and then do we know k? No. But we know t is 5,700. Again, a sub 0's cancel. I have 1/2 equals e to the 5,700 k Take the natural log of both sides. And then I'm going to get natural log 1/2 equals 5,700k. Divide by 5,700 on both sides, and I get k equals natural log of 1/2 divided by 5,700. Or this equals about negative 0.00011216. Okay, so this isn't what we were trying to find though. We were trying to find the years. So we wanted to know, let's go back to the question. Traces of burned wood contain about 1.67% of the original amount. So we're trying to find that 1.67% of the original amount. So we have, and we're going to change that percent to a decimal. So 0.0167 is our A of T, equals E, and then we found K of negative 0.00011216 times T. So we can take the natural log of both sides. 0.0167 equals natural log E to the negative 0.00011216 times T. We get that, and we're going to have natural log of 0.0167 equals negative 0.00011216 times T, divide by negative 0.001216 on both sides, and we get that T equals about 33,639 years. Okay, the next question says an object is heated to 100 degrees Celsius and is cooled in a room with an air temp of 30 degrees Celsius. If the temp of the object is 80 degrees Celsius after 5 minutes, when will the temp be 50 degrees Celsius? So this is a Newton's law of cooling. We're talking about temperature. We're given the temperature of the heated object after time t. We're given the temp of the surrounding area. We're given the initial, so that's why we're going to be using that Newton's law of cooling. So let's go label everything that we have here. We know the initial amount is 100 degrees Celsius. We know that the T equals 30 because that is the temperature around the room. And then where we have U of T equals 80, but we know time, U of T equals 80 after 5 years, or 5 minutes, sorry. So I'm going to go plug all of that in to what we know, the formula. So 80 equals 30 plus 100 minus 30, E, we don't know K, times 5. First, we're going to subtract 30 from both sides. So we get 50 equals 100 minus 30. And we can say that that's 70. So equals 70 e to the 5k. We're going to divide by 70 on both sides and get 5/7 equals e to the 5k. Take the natural log of both sides and we will get natural log of 5/7 equals natural log of e to the 5k. And then we have natural log of 5/7 equals 5k. Divide by 5 on both sides, and we get k equals natural log of 5/7 divided by 5. But what we were looking for is what will happen when we have the degree of the 50 degrees Celsius. So we are going to plug in back what we know. So we are trying to find u of t of 50. So 50 equals, and then that same step. So 30 plus 100 minus 30, and then e, we know k, we just found k, which is natural log of 5/7 over 5, but we're trying to find t, like how long did it take to be 50 degrees Celsius? So times t. Subtract the 30, we get 20 equals 70 times e to the natural log of 5/7 divided by 5 times t. Divide by 70, we get 2/7 equals e to the natural log 5/7 divided by 5 times t. Take the natural log of both sides. Equals, and then we can say natural log e to natural log 5/7 divided by 5 times t, which is natural log 2/7 equals natural log 5 divided by 7 over 5 times t. So we're going to divide by natural log 5/7 divided by 5, and we get that equals t equals about 18.6 minutes. Okay. Next, we are looking at this example, and it says fruit flies population in a bottle after t days is given by this formula. And we want to state the carrying capacity and growth rate. Carrying capacity if it's 230. So the carrying capacity is the max population, or as t increases to infinity, and the growth rate is your b. So first, we can figure out the growth rate because from our formula, it's what's in that exponent there. So our growth rate, and you want to change it to a percentage, so is 37%. Now the carrying capacity, if I plug in infinity for t, that brings this amount to 0. And then anything times 0 is 0, so that just takes out that piece of the equation, and I'm left with 230 divided by 1, which is 230. So the carrying capacity equals 230. Okay, so the initial population is when you have a sub 0, so p sub 0 p of 0 equals 230 divided by 1 plus, and then that is 56.5 e, and then if we plug in 0, we get negative 0.37 times 0, which is just 0. E to the 0 is 1. 1 times 56.5 is 56.5. So then I'm left with 230 over 57.5, which is about 4, and this is the population, so we're talking about 4 fruit flies. Next is a population after 5 days, so P of 5. We're going to plug that in, so 230 over 1 plus 56.5 e to the negative 0.37 times 5. And if you plug this in your calculator and simplify this, you get that this equals about 23 fruit flies. If you have any questions, please feel free to come ask.